will follow also depending on your requests. Um, it is my pleasure to welcome so many participants. We have people from Greece to Ireland, so covering most of Europe. I don't know how many are connected now, but above 80 have registered. Um, Let me introduce very, very shortly who we are, because many of the participants are not members of MCE community, and so they don't know who we are. Let me start a short, very short presentation. Here it is. Allora. Okay. So very shortly, let me say in one chart what is the MCE community. Our goal is to tell to those that are not members of our association, that we are very pleased to host in this webinar, that after we finish, we will try to contact them and ask them not only what they thought about the webinar and the content, and if there are further questions and so on, but also to offer, if they are interested, to explain what the meaning of the MCE community, what is our activity, and hopefully to convince them to become part of this community and could contribute to the value of it. So we are a platform for collaboration, exchange, and exchange of ideas, practices, solutions. And this is all about digital transformation, about smart cities, about services to citizens, about sustainability, including climate change management, about cybersecurity, EU-funded project, which is a topic of interest for many of our members, and etc. So we cover a wide spectrum of interest, and our goal is to support urban innovators and technologists to learn from each other and inspire innovation and tackle common challenges. We are a non-profit organization, and our goal is really the one written in this chart. We are not in any sort of business. We are our goal is to put people more and more in the same community and exchange experiences about it. By the way, we exist since more than 40 years. Formerly, we were called Major Cities of Europe. We are still the same, but we have changed our name because we think it's more MCE community is closer to our mission. And so this is a very short introduction. On purpose, I'm not going to explain anything in detail because we hope that many of you will ask, please tell me more about it, and later on after the end of the webinar. Now, just some organization matters. This is, as I said, a design for not technical audience. The webinar is recorded, and I start now the recording. Done. It should basically last 1.5 hours. We have muted all your microphone. It doesn't mean that you are not allowed to speak. You can speak, of course, if you want, but because we are many, we would like most of us to be on mute, and then if we have to say something, we can unmute our microphone. Please switch off your video camera because the bandwidth can be hurt if otherwise. The best way to communicate, chat for questions and comments is the chat, of course, and there is a chat in your screen on WebEx. And of course, you can switch on your microphone if you want to intervene. And in any case, the duration of the presentation will be about 1 hour, and there will be a debate at the end. Now, the two speakers that are going to intervene, one is Mauro Lavezzari. Mauro is a top expert in matters, and he has been working a long time with IBM in IBM labs and in many IBM technical leadership matters. And now he's working for another company, but overall, Mauro is the one who is really the top expert in AI. And I think you will appreciate the way he's going to present this first part of the webinar. Alessandra De Senen is part of the executive committee of MCE community, and she is the top contributor to our innovation ideas. And by the way, this webinar comes from her idea. Alessandra has a long career in also in IBM, Accenture, and she's a consultant, and she's also secretary of another organization related to rural society. And Alessandra is going to moderate the discussion and push on questions and so on. So this is what I wanted to say very shortly. As I said, at the end, we are going to come back to the key points. We are going to tell you that we are going to send you a questionnaire, and very simple one, to have your feedback, and especially to understand if you want to have further discussions and in-depth discussion about what we have organized, and in case we can also organize follow-ups. That's it for now. So I think I can hand over to Mauro and Alessandra to manage the meeting.
Thank you, Giorgio, for the introduction. Mauro Lavezzari speaking. As Giorgio said, I've been working for many years in IT services, etc., especially with IBM. And in the last year, I've been working also, and with a particular focus on AI-related products. I hope you can hear me correctly, and I will try to share my video, my display, in order to share the presentation. Can you look at that?
Yes, Mauro.
Okay.
Yes, please go ahead.
Okay, so as Giorgio said, this is an introduction of some concepts related to artificial intelligence. We are preparing. The idea is to have a couple of webinars. The first one, this one, is focused on AI models. So I think to the core of any artificial intelligence application, any AI application. The second webinar will be dedicated to AI agents and agentic AI, probably the part of the AI that is more on which a lot of people is working, and is aimed to implement complex business processes without the intervention of human being, or with a very limited intervention, working with intelligence components, the agents. And of course, the intelligence inside the agents are provided by the AI models. And in the end, the intelligence is always provided by these components. Just 2 words about the agenda. After a short introduction, I would like to introduce the AI with some contents about AI history, I think that could help in understanding some basic concepts. Then I will try to explain, trying to keep very simple concepts, the basis of and the logic that are used by modern AI models, called LLM, large language models. Then we will see the main topics related to the activities that have to be performed when we work with AI models, in general with AI application, what type of skill and what type of professions are needed. Then the further part is related to sub-attention points related to AI models, as AI models can have a behavior that is not ever what we expect, and we will see the main problems that can occur in this case. In the end, just a couple of contents just to introduce possible discussion about how we as human beings can relate to AI application model, AI models. About introduction, when you speak about AI, we talk about universe of areas, of different areas, different type of contents. We can speak with machine learning, the expert system we had in the past, robotics, the capability to manage feelings like the visual recognition, voice recognition, etc. And then we can go to more recent topics like foundation models and large language model and AI agent, etc. All of these areas have a specific contents and specific technology. Of them are interrelated. Anyway, a lot of different themes, different arguments to cover. But there is always a core part, the intelligence. The artificial intelligence is always provided by models, by AI models. They, as we will see during history, changed a lot, but always we can describe them at a high level as object with three main components: an engine, so the algorithm, the way in which they are executed; the experience, so the set of data that indicate the knowledge and the way in which they can be trained; and the settings, so how they can be trained, how their parameters can be defined in order to make them in a good shape for producing useful output. Let us start with something about history. I included here a sentence that is related to Alan Turing, that is considered, that at least I consider, the father of a theoretical definition of modern computers, of computer we use. Turing defined a theoretical machine called the Turing machine that is the explanation, the theoretical explanation of our computers. And Turing defined also a test and predicted in the 50s then an implementation of his machine, so a computer, one day would have been able to manage a conversation with a human being, so that the human would not have been aware about the fact that he was talking with a computer or with another human. That was predicted in the 50s, and we can say now that through our AI models that result has been reached. This test has been completed by modern AI application and AI models. And that is incredible from if you consider computers, because computers in the end are able to manage structured data and able to manage numbers. And they do that in a fantastic way, much better than a human. No? You can imagine a computer that in less than 1 second can find a specific content inside a huge data warehouse on a huge database with structured data, for example. But what is very complex for a computer is interfacing and humans in natural language is understanding natural language. Let us look at this example. If you have a database with name and birthplaces, it is very simple for a computer to give us an information about the birthplace of Albert Einstein, for example. But if you read the sentence and behind that, for us, it's very simple to understand that Einstein was born in Ulm from the sentence that you see. But it is very difficult to write a program to make a computer aware about that. That is, the explanation is that the computer, in order to do so, has to understand in a very good way the context and the meaning of everything is included in that sentence. And that is absolutely not simple. Now, not in the 50s, but about 15 years ago, we reached this result. And we had a very important step in the evolution of artificial intelligence. It happened that a computer was able to win a challenge inside a telequiz, a very famous American telequiz, where the host, the presenter, proposed some definitions, some clues, and the contestants had to push the button to fuzz in, and in a few seconds indicate the object of the thing that was related to the clue. A computer played a game with the champions of this telequiz, and was able to win in exactly the same condition. So it was able to interpret the question and give a response, a right response, in a quicker way, quicker than the human contestants. That was quite incredible and put a lot of interest on AI at that time. We are speaking about 2011, about 15 years ago. That computer, it was an IBM computer called Watson, was an example, a more advanced example of a cognitive computer at that time. But if we see how that computer, the logic behind this computer, we see that we can explain how it and understand how the logic that it used and why he was so able to give the correct answers. In practice, that computer was able to understand the question and then produced a lot of hypotheses about the possible answers. For each possible answer, the computer researched for evidences, looking at all the information that was available in his memory. For giving you an idea, the entire Wikipedia and many other contents were available in the form of documents in practice. And on the basis of the much more the strongest evidences found on one of the possible responses, it made a rank of possible responses, and the one with more evidences was the one that he proposed as as the response, as the answer. All of that was done in few seconds in order to be faster than humans, and you can imagine the capacity in terms of processing of that computer. But and how the evidences was found? that is just an example, just for giving you an idea on that. For example, let us suppose that the clue was about Vasco da Gama, a famous explorer. No, in May 1898, Portugal celebrated the 400th anniversary of this explorer's arrival in India. The computer get this input and try to find some sentences, something in his knowledge, in his memory, and find a sentence like this one. On the 27th of May, 1498, Vasco da Gama landed in Cape Verde. So, considering aspect related to the time, aspect related to the possible synonyms, some paragraphing, sorry, and something related to geospatial reasoning, so some correspondences of this type, the computer could find that this is was a very strong evidence related to the fact that Vasco da Gama could be the answer to this clue. So you see that in the end, this was like a very smart, very advanced search engine in the end, using many factors for arriving to a probable answer. And that is the way in which this cognitive computer worked 15 years ago. Now, 15 years ago, the people and researchers, etc., were asking in terms of what would be the next step, in what area we should make the most interesting progresses in AI. And among the other things, one point was indicated as the evolution in neurosynaptic system. So in intelligence objects, let's say intelligence arguments that started from simulating the human mind, the human brain. You see that this is an approach that is very different than the approach I tried to describe about that the cognitive computer that I described just right now. This is a new approach, and this is the approach that brought to the modern AI models. And now we arrive here, in our days. Okay. So these models simulating a human brain, were available also 15 years ago and also before. The problem was the possibility to implement something executing this model, because this model we see are, from the computational point of view, very complex. Now, the computer that won Jeopardy with was already very powerful, but it was very limited in comparison with what we have now, with the power of the current computers. On top of that, now we have graphic processing units, GPU, for example, for a famous NVIDIA company, that are that are perfect for parallel computing and give incredible results. And in the future, not tomorrow, but in the future, for sure, we will have a totally new type of computers, the quantum computing, that will have order of magnitude would be more powerful by order of magnitude in terms of parallel processing. So in terms of what is needed for an AI model. So we will have what I name brute force in advance in the future for having all what we need for executing these objects. But what is a simulation of a human brain? It is not so difficult to describe that. As at a very simple stage. You know that the brain includes two main objects, let's say, neurons and synapses, the link between neurons. So in the model that simulates a human brain is described in the same thing with two components. Neuron, this version is the simplest one, is named the perceptron neuron, and synapses, and the link between neurons. A neuron is something very simple in the end. You can imagine an object with more than one input. Every input have two values, 0 or 1, and every connection in input has a weight because the input can have different importance. Then there is a threshold value, and the logic is if the sum of the inputs multiplied by the weight is greater, is higher than the threshold value, the neuron is activated and the output is 1. Otherwise, the neuron is not activated. The output is 0. That's all. This definition is very simple, and it was in the origin, it was used for defining decisions, a simple decision support system. Now we had no time to go in deep detail here. We can do that, but the important thing is to understand that this object in the end has a description, a definition that is not so complex. Now, neurons are organized in neural networks. Neural networks is the base, the model of our modern AI models. All the neurons are organized in layers. There is an input layer on my left, on the left of the chart, an output layer, and then many internal layers. Every neuron is linked by other neurons through this connection. And for each connection, we have a weight. And every neuron has a threshold, a value of threshold. This is depending on the number of layers we talk about neural networks or deep neural network when the number of layers is greater than a certain number. That is the end of the description of the neural network at the simplest level. The complexity here comes from the size of this network. I don't know if when you heard about AI models, for example, for sure you know that there are ChatGPT-3, ChatGPT-4, and other famous names of models, and they are defined in terms of number of parameters. These parameters are the sum of all the weights and all the thresholds in this schema. The number of this parameter is of a size by billions or tens, hundreds, billions, and in some cases trillions, thousands of billions of parameters. So the size of this neural network at the basis of these AI models is this one, and that can you be aware about the complexity when we speak about the difficulty of finding the computers and the platform and infrastructure able to execute these models. There is another important concept to describe here: the possibility to describe as with numbers the meaning of objects. That is another very important step that was needed for really using these AI models. What does it mean? This means that we can relate anything with a vector with a series of numbers. And we can see if different objects are close to each other or not, depending on their meaning, using these numbers. Here we have a link. If you want, you can go there and see with a lot of examples on that. But for giving you an idea, you have a database in practice called a vector database, where all the things are stored and are close or far each other, depending on their meaning. For example, if you represent a dog, you see that in the picture, in the space in this database, dog is quite close to wolf and to cat, and is very far from apple. Because, and you can understand that the fact that they are close or far between other objects, depending on the semantic, depending of the meaning of this word. And also here, there are a lot of things to explain, but the point is that now we have a way for describing with numbers the meaning, the semantic of everything, of a sentence, of a word, etc. And that is another part that is absolutely needed for our models. Now, models, AI models are objects that have to be trained in order to be useful somehow. And we use the semantic, so that what I try to describe just right now, for doing that. But what does it mean to train a model? What is the difference from a model that is trained and another one that is not trained? The difference is related to the value of all its parameters. But billions and billions of parameters can assume some values. They assume some values in some processes that are inside the training. Pass a lot of inputs to the model, and it can get. And on this basis, through many iterative cycles, etc., the value of all these, all its parameters is refined until the output of a model start to give reasonable output, expected output from what was inserted. So the model, a trained model, can give right answers with a very high probability, for example, in a question answering case. How the model is trained? The first part is very, very heavy, very, very power demanding, and consists in feeding the model with a huge amount of text, documents, sentences, words. You can imagine not billions, but trillions of words and sentences that are simply that feed the model. That through some procedures, internal procedures, can make the model able to communicate, to be interfaced, and to work in natural language. So in terms of sentences that a human can read and pass to the model and can receive back. And note that we have to use a huge amount of data here, a huge amount of documentation taken from everything in the internet, any documents you can imagine. And this documentation is not prepared, is not explicitly prepared by humans. We simply use a lot of text and pass them to the model, basically. After this first step, that is very, very, that require a lot of effort, a very, very huge effort, we have a model that can manage natural language, but is not trained for any action, in any useful action, is not an expert in anything, cannot give any meaningful answer, or cannot execute any use case that could be useful. At this stage, there is another step of training, the fine-tuning. Here, it is necessary to have an expert preparing some specific data that is named labeled. That means that with the data, that is a description that is represent a possible input to the model, it is also it's related a label that indicates the right answer that is expected for this input. Preparing a right amount of label is possible to make the model, let's say, somehow expert on a certain context, on a certain argument, on a certain area. And so in the end, the model, LLM fine-tuning, where the parameters of the model are fine-tuned, the model starts useful somehow, start to be able to perform, to give some answers and to perform some actions. This type of tuning can be of different types, depending also on the effort that we can put on that and on the cost that we can face. We can have a full parameter fine-tuning, so all the billions of parameters are fine-tuned, and that is quite expensive. Or we can have several different types of strategies for optimizing, for fine-tuning let's say, one part of the parameters that are included in the, you remember the neural network that is at the base of the model. Anyway, after this stage, the model is able to perform his work. It's able to, in a question answering use case, it's able to give the right answers in a specific concept, is able to produce, let's say, to divide the input, to classify different input in different categories. For example, this is another classical use case for these models, and so on. The training of a model is not closer here. Now we have a model with fine-tuning, but the phase the phase of fine-tuning and monitoring and continue to adapt the model to be in order to have answers and output that remain of higher quality, is something that does not end at no phase in the life cycle of the model. So the training, there is a phase called post-training, where with other strategies, the model is continue to be somehow adapted and trained. You see here the acronym LLM. LLM stands for Large Language Model, and is based on deep neural network and on some algorithm, some logic that was evolved in the course of the last years, let's say. LLM and transformer is very interesting to look at how these models reasons in practice. What is the logic that is used here? That is different between the very smart search engines that I described before. Here I mentioned also transformers. Transformers is an architecture that was defined some years ago in 2017, and is at the base of the modern large language models. It was a leapfrog. It represented a very important evolution in the logic used by starting from a deep neural network. And so now all the models adopt this architecture. For example, that every one of us, or many of us, use inside our smartphones, is an acronym related to transformers. T stays from transformer. It's a generative pre-trained transformer, GPT. Okay, what is the logic? I took an example for a very interesting page that was produced by Financial Times. Here you find the link to that. It's very interesting and well made. I just took an example for trying to explain the logic here. So let us suppose we question answering case, and we want to put a question in input. What is the Financial Times? The logic used by these models is to capture the meaning of the question, of the input, looking at every word and trying to find the pattern behind this set of words in this order, and then produce a sentence as output, considering in a sequence of words and choosing every time in the sequence the word with more probability to the right one in terms of semantics. Somehow using also the possibility to describe things, to describe words and sentences in terms of meaning using numbers, as I said before. In the end, the model in practice try to build a sequence indicating all the words in this in a sequence, and then it can also consider set of words, and for all the group of words, it can define what is the highest probability to the right one. In the end, the model produces, in this case, the answer to the most the answer that in his logic has the highest probability, simply producing a sequence of words called the word in reality called the tokens, but for simplicity, and can consider tokens and word as the same, with the same meaning here. So in the end, these models are not search engines, are engines that are able to build sentences as a sequence of words that are the best, that consist in the best pattern in considering the input that was received. And it's difficult to understand that in that way you get, in a very huge amount of cases, a perfectly right response, a correct output. This, and remember that we start producing something from a model of our brain. So it's the approach is totally different. The logic is different. The result is the results we see every day, and they're continuously improving. If we have a similar object able to produce a correct sequence of 10 sentences corresponding to the right output, we could use that in a lot of different use cases. Of course, many focused on text, but not only text, because we can describe also images, and we can use the same logic also for producing images and working on that, or also other objects, not only text. So we can have a content creation, of course, question answering, summarization, so the capability to write a summary of a document in input. We can perform data extraction. We can extract data from documents in a completely free format, or analyze the sentiment analysis inside a mail from a customer, for example, or we can classify things into different categories. We can write programs. We can write programming code starting for the definition in natural language on the functions we need. For example, here, the progresses were incredible, were very, very smart, so that really now we can have in few minutes programs that implement business requests that are expressed in natural language. That are examples. And of course, we can find much more than that, starting from the logic I described. That complete the set of basics concepts behind the intelligence provided by models. That is the core of artificial intelligence in any application. Now, starting from this, now that more or less, and
Hey, Mauro, before we move on the practical aspect, I think that is important to take some consideration about the first part. First of all, thank you for taking us through this journey from where I started to where AI models are today.
Yeah, of course.
We know that this first part is very important because it's a technical part. We know that we have covered this key concept at a high level, but each of this topic could easily deserve a dedicated session in order to understand very well how what is this change of the approach from AI from the past. For this reason, I asked to our participant that if they want to explore any of these topics in greater depth, please let us know in the chat. And in this case, we can arrange another webinar in this part, in this technical part. Now I think that is important to understand how we can work with the AI model, and please go ahead to your presentation.
Yeah. Okay. So now
just a question, a technical question. I would ask Mauro avoid to move back and forward during the presentation because it is causing a very bad quality of the audio.
Sorry for that. Sorry for that. Now it's better.
Yeah. If you stay.
Okay.
If you if you avoid to move, it's better.
To move. Okay. Sorry for that. Okay. So now we can look at some basics about skills needed for working with these objects and the relevant profession, because there are totally new professions related to this new world, let's say. Okay, so in order to understand that, we can look at the typical steps that are present when we have to implement an AI solution, an AI application. We cannot go inside the details. Here, in comparison with the implementation of traditional solution, traditional application, there are the same problems and more problem, and something is more important than the traditional case. In particular, the data preparation, all what is related to data is crucial here, because if data are absolutely fundamental also in a traditional environment, here we can say that the data are the solution. So it is not possible to think anything running well in AI without a extremely careful focus on the data. Data means data collection, the capability to find the correct data and a complete picture that describes the complete picture of the context in which the model has to work. And then the data cleaning, so the capability to have data that are completely coherent among them and are expressed in the right way, and another time represent a complete picture of a context. And then the data are needed and have to be prepared for build data set for training, not labeled and labeled data, as I indicated before. And we have to build data sets for testing the model. That is another important part, another iterative part that is crucial in this type of projects, let's say. And then there is the part that is totally new, the part related to the models themselves, starting from the creation and the selection of the right models to use, to the part related to the training, and then to the model inference. Model inference is when you use the model, you pass input at the model to the model and receive the output. That is crucial, of course, in the test phase, but remain, of course, after the deployment in production, and also in deployment. After deployment, you have to manage in the best way the inference, and you have to monitor the model to control its behavior in a continuous way. Now, I said that we have one part that is present, was present also before, that are related to the data, that is much more important. And in terms of professions and skills, you have new skills here focused on data. For example, data analyst is still available, of course. In a traditional environment, the data analyst have at disposal some data in data warehouse, in databases, and have to extract from this base the more interesting and relevant information. Here we have a figure of a data scientist. The data scientist is a sort of superset of a data analyst. Data scientist does not start with a defined set of data. Data scientist has to find the correct type and the correct contents in different forms in order to build the data that will represent the future knowledge of a model. Then it has to manage all the cleaning phase, etc., the refinement, and then is inside the team that train the model. He has to select the model, to participate in the model selection, to participate in the model training, etc. So it's something focused on data, but in a broader sense than before. Then there are new professions, new skill. The AI engineer that has to provide all the things related to the infrastructure, the computers, the infrastructure resources, and all the processes for deployment of a model, etc. Here we have the same problems, the same topics we had before, but we have also other other issues, other topics, because putting in deploying a model and using a model through a model inference is not like deploying and using a traditional application. There are other things to consider. And then another important profession, completely totally new profession, is the prompt engineer. The prompt engineer is the expert in preparing the input to the model. The input to the model is named prompt and is a document. It's a set of sentences. It's something that is defined in natural language. So don't think a prompt engineer as a programmer or something, or someone working in developing code. Developer engineer is first of all an expert of a context in which the model have to be used, but not only that. Let us try to understand better this concept. Before all, the prompts, the preparing of the prompts engineering is an iterative process. There are many cycles in which you prepare the input, so sentences, and you see inference the model, and you see what is the output from the model. Depending on the output, you can trying to change the way as the prompt is prepared, and so on, until you reach good results. And the prompt is something that is much more complex than what you can imagine. When you use ChatGPT in your smartphone, you simply put a question, ask for a question. Nothing, not much more than that. But when you prepare prompts for a new AI application, you have to consider also what you need is to have an answer, so a question answering use case. You don't have to include in the prompt only the question in natural language. That is one part, but you have to give instructions to the model, because you could ask for having the question, the answer organized in a specific style, in a specific way. You have to describe the role that should be covered by the model. You have to, and that is very important, you describe the context in which your question is important, also in the input. And you have to express the question in a very precise way. There are different techniques also for proposing a question. For example, zero or few shot prompting. What is a shot here? The shot is an example. You can provide in the input a set of examples with the expected output from this example. And that you can put these examples in a certain number inside the input, inside the sentences. That can help a lot the model to give a correct response. And so on. You could also propose to the model in the more advanced AI models, LLMs, to split a complex request in more steps, so that the model can iterate and solve what is required in different steps, making something related to reasoning. That is another possibility. Anyway, you can understand that preparing a prompt is not so simple and it's not so immediate. On top of that, you can define the behavior of a model also in other ways. There are other parameters, not the billions of parameters that we have, that I have already defined, but other parameters that the user can set. For example, for limiting the number of words in output or of token in output. So for having a more short response, and or you can give some configuration for having a model that is more or less creative, so that where the possible answer can be more. So the behavior of the model can change according to many of these possible configuration. But let us take an example for a prompt. This was taken from a training inside an IBM course. The situation is this one. In this case, we ask to a model, to an LLM, to produce a marketing communication to the clients of a bank. And so a mail, no, that have to be sent to all the clients, because the bank has a new account with some features, and there is an offering that has a certain duration and so on. So on the left, you can read the prompt what was prepared, no, a short 5-sentence mail, including the features and the contents that are indicated in the prompt. And on the right, you see the response from the model. Of course, the team choose the type of the model, a specific model with a specific configuration, and in the end, this is the answer from the model. So the mail to send to the clients. If you see in the end of the output, there is a sentence that is quite strange. Because the model indicates that the client can call at a certain number for having more information on the offering. And you see that this information, this number, is not indicated in the input. So why the model prepared this output, gave this output? Because this is an LLM, and it decided that the sequence of words to produce for that prompt included also that number. It's not something that is can be fully understood. It is related to the logic of a model. Now, how can we refine the model if we don't want to see that number? We can repeat the prompt, but we can add to the prompt some more instructions. No, in this example, you see in the end, we add do not include any other information not provided above, and that the model gave a good response in this case. Not that the sentences are different. The model did not remove only the number, but changed the text with some logic that it used. And this could be an example of a model refinement. But this is a simple example. It's not so simple in many cases to get the right what we want, changing the prompt. It's a science. Someone say it is also an art, and it is a profession, very well paid, by the way, in many cases. In the end, prompt is a very important thing. It's the input to the model, and it have to take in account many factors, as I indicated before. Not only the strict request, not only the question, or not only the instruction for doing what we want. We have to add a lot of contents for that. And then the last indication about the activities, the current activities. Many current activities on AI are focused on agents. Agent, as we will see in the next webinar, is an object that have an intelligence, because make inferences with a AI model, with an LLM, but is also able to act, to produce actions using tools, and has a memory about the past operations that were provided. Basically, through an AI agent and through a group of agents organized in an agentic AI workflow, it is possible to replicate very complex business processes. And that, of course, is a topic on which a lot of people is currently working. We now have seen something.
Sorry, Mauro. I think that before we move on the next part, I like to make a comment because I think that what you have described in this part, I think is a very important element of our webinar, because what you have described requires significant expertise, time and investment. Okay, for most medium or small organization like municipalities or SME, building or training an AI model is just not an option. Their challenge is how to take an existing model and adapt it to their own context. Let me ask you two questions. The first is, you highlight prompt engineering as an emerging skill. It seems to me that it's becoming a critical capability for adapting a general purpose AI model to an organization-specific model. In your view, in your experience, who should own this capability? Should it remain within the IT organization, IT department, or should the operational department also play a leading role, given their knowledge of operational and services delivery processes? The second question is about the data. One of the strongest messages I take away from your presentation is that talking about AI really means talking about data. Now, data has always been at the center of information system. So why is everyone emphasizing data today? What has fundamentally changed, and what is the key message for organization about data and AI model?
Yeah, okay, thank you, Alessandra. Let us start from your first question. What is the from where the new experts, the prompt engineer are coming? No, what is the base preparation? There is a deep change, in my opinion, because the importance of knowing the traditional IT topics for working on models somehow is still important, but is absolutely not important as to have an experience in the context in which the model have to be used. There are two important factors for a good prompt engineer working on a model: the knowledge or the capability to understand the contents of a specific context in which we are working, and then have to be provided or directly by him if he is an expert on that, or he had to be able to talk in a very good way with the business experts, the context experts. And the other factor is the knowledge about the logic in which the model runs, about its internal architecture. I gave in the first part of my presentations just some basic things, about the partner matching, about the neural networks, etc. You don't have to be an expert on that, but you have to have a good understanding about the logic, let's say, of in which an LLM among brackets reasons. These are two very important things. But I think that knowledge, the expertise in the context is absolutely fundamental. And you can think that okay, Giorgio sent me a few days ago an article from The Economist, no, that indicates that now many companies working in AI and also implementing and training models, etc., are searching for people coming from philosophy high school. And that is very funny because, you know, in the past, someone studying philosophy was someone that shouldn't have the same opportunities in the job as a programmer. Then it could be could be changed a lot in the future, because the type of skill required is changing a lot. And another question was about the data. Data is absolutely crucial. Now we will see some examples in the last part of the presentation. But data here is the real starting point. So it is not possible to think that a model and so an AI application can work correctly without a complete set of right data and a set of data that is correctly used in training and in testing. Is something, in my opinion, completely strictly related to the same object, to the same model. The intelligence is nothing, cannot run at all without correct data. A correct data is not only a data that is true, it's not only data that include correct information, but have to be data that are precise, that are coherent each other, and that are complete. We will see this concept in a few minutes in the last part of the presentation. I don't know if there are other questions or if I can go ahead and tell me, because I have no
I suggest go ahead, and at the end we start with the question and answer.
Okay. So the last point, attention points on the AI models. So an AI model could behave different than we expect. There is an important thing to always take in account. That was valid also for the cognitive computers in the past years, etc. AI is something related to probability. In a cognitive computer and an AI model give responses that are good, that are right, always with a certain probability, perhaps a very high probability, a 99.99%, but there is no 100% right response. And that is something that has to be always taken in account. Now, what are the possible problems we can have? Several ones. One of them is the bias. Bias is when the results of what we ask to a model is not really balanced on the data, on the aspects of the context in which the model is working. That could have a very big, very important consequences. Because think, for example, at an environment where artificial intelligence starts to be used a lot. The human resources areas where you have to evaluate a curricula for someone that is trying to get a job, or you have to evaluate the results of an employee. if if you is a model, an AI model is working on that, is helping you and give some results, think about the fact that the model has some biases related to the status of employee, his sex, his place of from where he came, etc. And that is possible. That is possible because when you provide data, and another time the data, and when you provide and when you perform the refinement, the fine tuning, the test, etc. If you introduce something related to prejudice, to stereotypes, or something like that, and sometimes that is possible also without an explicit intention from the trainer. That can be due to the normal way of thinking, no, of the team. That can produce these results. How can we improve that? Another time, we have to have a very careful look at the data, at the completeness of the data and the type of the data that do not have to include any type of deviation from the right contents. And so in this simple slide, I included something that was real also in the old traditional world. Rubbish in input produce rubbish in output, but that's in particularly true in this case. Another problem is hallucination. Hallucination is when the model produce an output that perhaps is well organized in terms of sentences, etc., but simply is wrong. That can happen. We are always looking at things that have a certain probability. So that can occur. I remember one time, some years ago, when Google announced and presented a new model, and in a question answering demonstration, if I remember well, about an observatory Hubble, I don't remember well what was the question. The model gave an answer, a very good answer, but that was wrong. Here the consequences were in the finance stock exchange, because Google lost a lot of value in the day after. Of course, was only temporary, but the consequences were quite hard for them. Why that occurs? That can occur for many reasons. Another time for data, of course, because data can be wrong, the initial data, or data can be not available. You can, in a question answering, if you forget to put the needed information for an answer, the model will try to, when you put this question, the model will try to give an answer in any cases, because what it is do, remember, is always to build a sequence of words in a sequence, trying to replicate according to a pattern that he wants to replicate in somehow. And so the answer can be available, but it could be wrong with a high probability in that case. And another problem could be the generation of the response, that could be related to the fact that you choose a model that is not perfectly aligned with the type of use cases you are interested in. There are models that are trained for certain use cases, not for other. There are models that are very smart in programming code generation, for example, but are less good for other use cases, for example. And that is another possibility. And a big cause, a very important cause, could be the prompt. And another time we come back to the importance of the prompt engineering. You can, if you propose a prompt that is not enough detailed, that is not enough complete, you can get wrong responses. Let me take another very stupid example. If I ask to ChatGPT if to tell me something about the Second World War, so about an argument so vast, so complex, you can understand that the response could be very, very long, by the way, but also could include a lot of different things, and perhaps also something that is not perfectly right. If I ask to ChatGPT to indicate me the main battles, the most important battles in the Second World War, this is another prompt. This is another question that is quite general, but much less general than tell me something about the Second World War. And so the probability to have a wrong output in this case is much less. So the prompt is very important. And so how to reduce the hallucination? Of course, review the prompt before all, or and perhaps put it some examples about so to precise what I would like to receive as output, or in the worst case, I have to get better data and repeat some tuning, for example. Model quality and drift. Here the point is that the monitor of the model, also when the model is in production, is very important and is not so simple. Depending on the use case covered by the model, I can introduce several ways for monitoring and for evaluating the model on the basis of the classification of the input, or in basis of the answering to some questions, in terms of indicating how the prediction of a model is far from the real occurrence, for example. In all these cases, there are concepts, there are algorithms, there are ways to measure the quality of the model. And that has to be done always during all the life of a model, because in order also to avoid the drift. So the fact that in production, the model that was very smart at the beginning started to give bad output. And that can be due to the fact that the context change. Think of a model that have to eliminate, to detect, identify spam, bad emails. The model can be very smart at the beginning, but if during with times of the definition of a spam changes, so the spam is modified, is include other contents that were not in the training set. Of course, the model will have some drift, won't perform a correct work. So it is important to continue to monitor the model, and it is very important the model governance. That is a concept larger than the simple monitoring. The model has to be evaluated, and in terms of many aspects. Some aspects, for example, are related to the transparency and the explainability. A model can be, a response for a model have to be correctly interpreted and have to be understood by humans that want to understand why the model gave this response. So the model usually are provided with a set of training data that were used, with indication about how the model was trained, when tested, etc., and with some information about his structure, and so in the way in which it apply its logic. It's a concept that is very, very important. Another important concept, for example, is the privacy and security. The the model does not provide data in the response that are considered as a private data, for example. And think about, there are many ways for testing the model about security and privacy, that can be teams of specialists in prompting that prepare bad prompts, a sort of malware prompts, in order to see if they can be able to extract from the responses of a model private data or something that exposes the company, etc. This is an example of governance on this object that is managed in a way that is significantly different than the way in which the security is managed for traditional applications. Model has to be able to define safeguards, limits in terms of its behavior, in terms of the word that it can include in the responses, in terms of the data that it can provide, etc., etc. And of course, models have to be compliant with regulation that are available and that have been and will be defined. Europe in particular defined very important regulations. They are not so defined till now, for what I know, in US, but in any cases, that is a request. In general, so monitoring and in general, more broadly, the governance of a model is very, very important. The last comment about the cost. When we have to face a project for including an AI application, and so an AI model, we have to think at our budget, because we have many different choices. Choices start from the selection of a model to use. We can choose very large models that are some advantages, but they could be very expensive, because if we inference a model of this type, many times the cost of the response is in terms of a quantity of processing power that is used for the model, and also in terms of the complexity of the response that is provided. And so choosing a light model, perhaps developed, implemented for being very smart on a specific use case. If I am interested in that use case, I can choose that model and I can save a lot of money, for example. Then there is a lot of things related to the deployment and the maintenance of a model and the hosting. And so usually I have to work with models in software as a service. So I have to go in external environments where models reside in huge external data centers in cloud, for example, and they can use AI in that way. But some companies cannot afford to export in the external world some data that could be in the input of a model. And so it is ever and ever important to have something that can be implemented in a local data center. That was quite impossible in many cases in the past, but many companies, included the company, the major company working in the AI market, are working hard in order to reduce the need of processing power, so that in some cases now we can think to use models locally in a local data center, for example. And so in the way we produce the pre-training and then the fine-tuning, there are different ways, and they can imply more or less resources and effort and cost. So there are many things to take in account. Okay, in the end, just a couple of contents just to not about these models and in general about AI. This man is Arthur C. Clarke, is a very famous science fiction writer. And one of his sentences, any sufficiently advanced technology is indistinguishable from magic. then this concept can be applied also to AI, in my opinion, because sometimes AI, the response for a model is considered as the truth, and that is a problem because not always we don't have the perfect assurance that a model gave the right response. There was an interesting case test organized by the Harvard Business School with Boston Consulting Group consultants, in which different consultants from Boston Consulting Group were required to produce some work, some consulting, and using some tools with AI, and another group without AI. Of course, the result was that especially the less prepared, the junior consultant, etc., working with AI produced in a short time a very good results comparing with the same results without AI, and that is of course understandable. But when AI gave wrong results, wrong outputs, the results from who worked with AI were very bad in comparison with the others. That means that the wrong response from AI were taken as right response without any evaluation, enough evaluation from the human being. That is something that, in my opinion, is a problem. And at last, a sentence from my preferred science fiction writer, Isaac Asimov, that was able in the 60s to imagine a world with robots, with machines able to think. Is very similar to what is happening now. And he described in many books the same problems that we are facing now in terms of will humans lose jobs, and what is the relationship with the artificial intelligence, etc. So he said, I don't feel robots are monsters that will destroy their creators, because I assume that the people who build robots will also know enough to build safeguards into them. And in his fantasy, robots have internal safeguards. They in their architecture, they were not able to damage human beings. Now, what I'm thinking now is that these safeguards are not available in our artificial intelligence, and that is something that, in my opinion, is the first issue to face in order to avoid very big problems in the future. Okay, that's all, and I hope to pass it you some interesting concept and some basics for perhaps better understanding this new world of artificial intelligence.
Okay. Thank you, Mauro. Very interesting presentation. A lot of people say the very informative webinar. It's very late, but I think that we can start with the question and answer phase. There are some questions in the chat. I see that the first question is from Paolo. Paolo, can you ask directly to Mauro your
Yeah, the question is very simple. I wrote in the chat. The question is there any estimation about the number of available models now in the wild, I would say, not only commercial, but also open source that can be really used in order, and if there is any guide that can help people that want to select a model for their application in order to select the right one if there are so many.
Yeah, this is a very, very good question. In general, the evolution of this world is incredible. So many times I study something that is new, And when I finish to really understand that, there is another thing that changes the situation, and so I have to start from scratch. It's very difficult to remain in contact with the evolution that is very fast. And that is particularly true for models. There are a lot of models and more models available. Now, the trend is that models, there are very complex, huge models in terms of parameters, but there are also a lot of new models that are lighter. They have some tens of billions of parameters in comparison with, for example, more than 1 trillion parameter of GPT-4, just for having an example. And they start for covering specific use cases. Now, the question is, how can we understand what is the best model for my specific needs? And that is not simple. But there are also many open source models, but also the proprietary models usually provide a set of indications, not only the complexity and the training history, let's say, but also the use cases for which the model have been implemented. For example, under Hugging Face, you can find a lot of open source models, and you can start trying to understand the use cases for which the models have been implemented. I repeat, code generation, question answering, the usage with agents for implementing a chatbot, so managing a natural language conversation, etc., etc. So the number is increasing, the number of a model. The specialization is is ever and ever more and more different, but also the documentation is standardizing, and you can find some interesting documentation for the core starting point.
Okay, thank you. I don't know if there are other questions. I see in the chat a consideration from Lorenzo. I agree about you, Lorenzo, because he said that what's important to learn how to ask an AI model to generate the best possible prompt. And I think that in order to do this, we can organize and so on, where we use with the participant.
Yeah. If there is some echo. Anyway, if I can make a funny comment on that, because I tried many times to interface models, etc., with prompting. The way in which you ask, if you ask to have the output, is very funny. I tried, for example, one time to ask it to have the answer in terms of a poem. So I said, you are a poet, and so give me this the answer of this question in form of a poetry. And the model gave me the response with rhymes, you know, so like a poetry. So the possibility to define also the way in which you want the answer is very impressive, and that okay, seriously speaking, the way in which you prepare the prompt, specifying a lot of things outside the contents of a single question. That is important. You have to be very precise, very complete, and in that case, you have a very high probability to have a very good response from a model.
Giorgio, do you have any question for Mauro?
Yeah, I have a question. Now, let's assume that I am managing an IT department of a city, and I want to make I have a specific problem, and I want to find the right product to develop it to be used for that, and using artificial intelligence, it could be more effective. The question is about cost. How can I build the business case? I mean, usually we identify a product, we know what is the cost, and we can imagine the business case. In the case of artificial intelligence, how would you imagine that we could build such a business case in which, in reality, there is a lot of work to be done around which we don't know really. It's a little bit uncertain how much it is.
Yeah. It's not as simple. There is not a simple answer here. The budget, the evaluation of an estimate of a cost for a project, including an AI application, in my opinion, cannot be done without some basic decisions. The decision could be related to the choice about what model to use, about the fact that you think you have to train or fine-tune a model or not. And when you have decided, for example, that you will use a certain model in software as a service, and so you use some techniques for indicating your context without any additional training to the model, and that there are ways for doing that. You have to consider at this point the frequency of the questions or the frequency in which you will interface the model, because the cost is related to the amount of tokens. So let's say the quantity of sentences in input and in output that will be provided. So, and in some sense about the traffic that is produced. But I repeat, there are many different components that have to consider in order to define a complete estimate. That is not, by the way, that is not strictly related to models, because usually you have in that case to consider the implementation of an agentic workflow when we have to define a solution, an AI solution. Now that means to provide a workflow based on agents. And so it is true that you have to select the model, etc., but you have also to consider many things related to how to organize the model interaction, the action, and so the tool that you have to use. So it is not so simple. You have to go in the specific case and start considering the type of models that you can use, the relevant cost, starting from that, and that there are a series of other things. There is no, let's say, a rule of thumb, something that is general and that you give an idea about your possible cost. I think we have to consider the specific case.
Thank you. Alessandra, I think, is there any other question?
No, in the chat, they aren't other question. I think it's very, very late because then to
Yeah.
6, and I think
Yeah,
that
we are 15 minutes late, so it
exactly.
is okay, 20 minutes. So let's say the following to conclude. First of all, the recording of what we have said and discussed today will be put online in a few days. It takes a little bit of time to shape it properly on our website. And I have the list of the registered people, not only the ones that are now online, but also the others that could not participate. You will have the link to download it and listen to again or share with your colleagues. It will be open. Second, you will get some questions about your feedback, about what your suggestions that you would like to understand for the future and to develop for future webinars. As I said, we will have a webinar after the summertime. We will send you the exact date about agentic AI, which is the evolution of what we have discussed today. But this is not the end. So we are open to listen to you. And by the way, if you feel that what we have developed was not good enough, please tell us. We are very, very interested in listening to you. Last point, but very important, many of you are not members of our organization, of the MCE community. As I said, we are a non-profit, but the quality of what we do is dependent on the quality we get from our members. The same as agentic AI. I mean, you are our prompts. And so we need more members which are eager to share their experiences about innovation in general, not only about AI. And so we will, to those that are not members, we will send a message asking if they wish to learn about what it means to be our member. We will be pleased to have a call or to have a mail and describe it to you so that maybe some of you will decide that it is worthwhile joining us. By the way, this year, differently from the past, we have decided that our webinars are open to all possible people that are interested, members and not members. So the other ones you will hear about will be in the same shape. So please participate and hopefully decide to join us. Many thanks and many thanks, Mauro. This was again a great. You did great. I was really fascinated about what you were describing.
No, okay, I always try to simplify. So please don't take this all what I said as the complete explanation of very complex process. As Alessandra said, every topic could be the argument for going deeper, and so we can see many other things. Here the goal was only to simplify a lot and to give an idea about some concepts.
So I can summarize saying that what we presented was the result of man intelligence, and then we will go through different steps later on. Thank you so much, Mauro. This was great, and thank you so much, Alessandra, for coordinating that and for the idea you brought to have this webinar. And so this is what it is. If there is any other comment or questions, I would like to close. Apparently not. Well, I'm very pleased that I would say 100% of the people were continuing following the presentation, doing all the sequence of the discussion. So thank you so much, and I will stop now. And